Hello and welcome to 𝐒𝐻𝐞𝐫𝐤𝐲 channel. In this video, I'm going to work on exercise 2.2 of Primary Mathematics Workbook 5. And this exercise is about reflection or lines of symmetry. Let's start with question number 1. In question number 1, it says, spot the difference. We have the picture here and we are asked to spot the difference. Draw shapes on the right side of the picture to make it a reflection of the picture on the left. The picture on the left over here is the complete picture, and on the right we have some missing parts. So to make the right side a reflection of the left side, we have to draw some missing pictures there. The first thing that is missing is the window on the tower. So I have to draw a window here so that it should be complete. Maybe it's not exact the same, but it makes you understand, at least it makes you understand how to do it. And the other thing that is missing on the right is the moon. So the moon is over here. And there are 5 trees that are missing. So the trees are here. The one over here is bigger. This one is bigger. And the one behind it is smaller. This one is smaller. And there are 3 others. Another smaller one is here. And one bigger one is in the center. This one is in the center. And another we have in front of that over here. So the trees are also complete. On the left, we have a board, and there are 2 boxes on the board. But one box is missing on the right. To complete it, we have to draw this one also. Okay, now we are done with the mirror image from the left side to the right side. Let's now move to question number 2 and see what we have there. Let me scroll it a bit down. In question number 2, it says, Zara says that she is thinking of a triangle with 3 lines of symmetry. Draw a ring around the name of the triangle that Zara is thinking of. We have a scalene triangle, isosceles triangle, and equilateral triangle. A scalene triangle, you know, is a triangle that has the sides of different sizes. And an isosceles triangle is a triangle that has 2 equal sides and 2 equal angles. But an equilateral triangle is a triangle in which all 3 sides and 3 angles are of equal sizes. So the triangle that has 3 lines of symmetry is an equilateral triangle. So this is the correct answer. Let's now move to question number 3. In question number 3, it says, shade the squares to make a pattern with 1 line of symmetry. With 1 line of symmetry. So the line of symmetry, we can choose this mirror line, and we have to color this side in a way that only 1 line of symmetry should be over there. So to do so, we draw or we color this one, the one here, and the one on the corner here, 2 of the ones here, and also this one, also the square here, this one, and this one, and the last one here. Now this shape has only 1 line of symmetry, which is here. This is the line of symmetry, because if we draw this line, both the left side and the right side can be the same. But if we draw a line here, it cannot be the same because the shaded parts are not the same on both sides. So now this shape has got only 1 line of symmetry. Let's scroll down to move to question number 4. In question number 4, it says, predict where the reflection of the triangle will be after it's reflected over each of the mirror lines. Draw your prediction using a ruler. Because over here we don't have access to a ruler, I will just predict and draw it with my pencil. So the first one which can be reflected to the left can be like this. Like this. We have to consider the distance from the mirror. We have to consider the size of the triangle because it can be exact the same size, but on the other side, which is a mirror image. We can reflect here. Again, we have to consider the distance from the mirror. Okay, because this is prediction, it cannot be exact the same as the actual one. And one can be here, one can be here, so we have to consider the distance, and one can be here, over here. Okay, so we could predict the horizontal and the vertical reflection of the triangle. But here it says, check your prediction by placing a mirror along each of the mirror lines in turn. Look at how the triangle is reflected. Check the predicted reflection that are correct. Use a different color pencil to correct the prediction that are wrong. You can do it on your book. You can first predict, or you can follow the same way that I did, and then check by a mirror, choose a small mirror, and reflect it and see if it is the right way or not. Let's now move to question number 5. So let me scroll down. In question number 5, it says, use a ruler to draw all the lines of symmetry on these triangles. Use a ruler to draw all the lines of symmetry on these triangles. First of all, we have to identify the types of the triangles. We know that the isosceles triangle has got only one line of symmetry. Equilateral triangle has 3 lines of symmetry, but a scalene triangle does not have any line of symmetry. The first shape, or the triangle A, has 1 line of symmetry because it's isosceles. I cannot have access to ruler, but I can draw the line of symmetry. It can be over here. This is the line of symmetry because it cuts the triangle into 2 equal parts, which can be a mirror image of each other. Triangle B is a scalene triangle, so this one does not have any line of symmetry. So no line of symmetry. No line of symmetry. Triangle C is also a scalene triangle, so it does not have any line of symmetry. Also, no line of symmetry. But triangle D is also isosceles triangle. So it has got a line of symmetry, or it has got 1 line of symmetry, and it's here. The line of symmetry for this triangle is here. Triangle E is an equilateral triangle. So it has got 3 lines of symmetry. 1 here, 1 here, and 1 here. So it has got 3 lines of symmetry. In this case, we can say isosceles triangle has got 1 line of symmetry. A scalene triangle does not have any line of symmetry, but equilateral triangle has got 3 lines of symmetry. Let's now move down to question number 6. In question number 6, it says, shade 5 squares in each of the empty quadrants to make a pattern with 2 lines of symmetry. So on the top left quadrant, we have 5 shaded squares, and we are going to shade 5 squares in each of the quadrants so that we should get a pattern with 2 lines of symmetry. So to do so, I will shade the one opposite to that, and also the one here, and this one which is opposite to the 2 shaded parts here, and also here. 1, 2, 3, 4, 5. So 5 are shaded here, and this one also I'm going to shade. This one also, and here opposite to the other one, and this one also. So 5 are shaded here, 1, 2, 3, 4, 5. The same way, I shade 5 squares in this quadrant. So 2 here, 1 here, and 1 here, and 1 over here. So 1, 2, 3, 4, 5. Now it is shaded in a way that it has only 2 lines of symmetry. 1 line of symmetry is here, and the other one line of symmetry is here. It does not have any diagonal lines of symmetry, so it has only 2 lines of symmetry. Now let's move down to question number 7. In question number 7, it says, reflect the square, triangle, rectangle, and pentagon over the horizontal and vertical mirror lines until you make a pattern with reflective symmetry. A pattern with reflective symmetry. So first we start with this square. This square is reflected on this side, and it can be over here. It is over here. In this one, and the triangle which is here can be reflected on the other side. Let me count the squares. 1, 2, 3, 4. So 1, 2, 3, 4. The triangle can be here. Now we reflect this rectangle over this mirror line. So it can be drawn this way. One line here, one line here, and the other line here. Now this one is a reflection of the one here. In the same way, we can reflect this rectangle on the right side. So it can be reflected this way. So a line can be here, here, and here. Now this is a reflection of the one on the left. And over here we have a pentagon. To reflect it to the left, we draw the shape here. Okay, the pentagon is also reflected. And now I reflect this pentagon over this mirror line. The mirror line, which is here. So 1, 2, 3. It is apart 3 lines from the mirror line. 1, 2, 3. So it can be here. It can be right here. So we are done with reflection of this pentagon over here. Now I reflect this pentagon on the other side of the mirror, on this mirror line. So it can be here. It can be over here. So let me shade this one also. Good. Now we have the pentagon on each of the quadrants, but we don't have it, but we don't have the rectangle. So this rectangle should be reflected there, this way. Okay, this is also done. And the triangle is missing here. So it is apart 1 line. It can be over here, the triangle. This same triangle can be on the other side also. 1, 2, 3, 4. It is apart 4 lines. 1, 2, 3, 4. So the triangle can be here. The triangle is over here. Now we have the triangles also on each of the quadrant. Then we have to reflect the square on each of the quadrant. So the square should be here also. The square should be here also. And we are done with all the shapes. We could reflect all the shapes in each of the quadrants. Let's now move down to question number 8. In question number 8, it says, choose 4 different colored pencils or pens. Use them to shade in the squares and half squares marked with stars. Reflect the pattern over the mirror lines and color all squares to make a pattern with 2 lines of symmetry. Here we have to consider that we have to make a pattern with 2 lines of symmetry. So I will use 4 colors. I will use yellow, dark blue, green, and red. So let's start with the yellow. Okay, I will shade these parts with yellow. This one here, and this one also. I will shade in a way that it gives me only 2 lines of symmetry. Only 2 lines of symmetry. Okay, let me make it a bit more proper. Now I use the dark blue and shade this part. So here, and the one here, over here also. I will shade all the half squares and the squares which are start. Okay, we are done shading this part also. Now I will use the red color and shade the centers here, here, this one also. Okay, we are done coloring the red one also. And the last one is the green color. So I will shade these parts with green. Okay, we are done shading all the start squares and half squares. Now let's reflect this pattern to the right here. To reflect, this part can be yellow, the same as the one on the left side. To reflect, this part can be yellow, the same as the one to the left. Okay, let me shade all of it. This is now exactly the same as the one to the left. In the same way, I will reflect the dark blue on this side. So here we have dark blue, all the full squares and half squares on this part can be dark blue, so that it should be exactly the same as the one on the left side. Now I will use the red color. The red is also the same as the one to the left. Okay, we are done shading the red one also. Now the green one. Okay, the green one also should be shaded properly. So I'm done shading this side also. Now we have to reflect this pattern down here also. Reflect down here also. So first I will shade the blue one, the dark blue one, which is a reflection of this part. If it's not that proper also, but it makes us understand that it will have only two lines of symmetry. Only two lines of symmetry. Now the yellow one. So the yellow one is here, which is a reflection of the one here. Okay, let me make it a bit more proper. Okay, we are done with the dark blue and the yellow. Let's now shade the red one. The red one can be here, here, in these parts. Okay, we are done with the red one. Now we will shade the green one. The green one is here. This is the green one. So we are done shading three parts of the pattern, and only this part is left. So here also we have to follow the same. First I will shade the yellow one. Then I will show how it is having only two lines of symmetry, because it is asking us to make the pattern in a way that there should be only two lines of symmetry. We could draw in a different way also, but it was not able to give us two lines of symmetry. It would either give more than two lines of symmetry or less than two lines of symmetry. Now we shade the dark blue here. Okay. The dark blue is also done. Let's now shade the red one. Red one here, here. We are done with the red one. Let's now shade the green one. Green color. The pattern is also now a good looking one. Okay, we are done shading all the parts. Now, how should we know that it is having only two lines of symmetry? If we draw a line from here, let me choose a different color. I will choose the blue one. Okay, if we draw a line here, this side is not the same as this side, because if it's reflected on this line, this one can be here, which is not the same. In the same way, if we draw a line from here down here, it is also not a line of symmetry, because the side to the right is not the same as the side to the left. It has only two lines of symmetry. One line of symmetry is from here. Let me choose the red one. One line of symmetry from here. This is one of the lines of symmetry. And one line of symmetry from this diagonal one. Means now this shape has two lines of symmetry which are diagonal lines of symmetry, but it does not have the horizontal or vertical lines of symmetry. Hopefully we are done with this question now. Let's scroll down to question number 9. In question number 9, it says, this is a chessboard. The chessboard is given over here. Part A says, how many lines of symmetry does a chessboard have? A chessboard has two lines of symmetry because it has only diagonal lines of symmetry, but it does not have horizontal or vertical lines of symmetry. The two lines of symmetry that we can find is this one this one and the one from this diagonal. Okay, now it has only two lines of symmetry. It does not have horizontal or vertical lines of symmetry. I can write two lines of symmetry. Two lines of symmetry. Okay? Part B of this question says, where could you place a counter on this chessboard so that the chessboard still has two lines of symmetry? Two lines of symmetry. So the counter that we can place can be here. It can be over here. Let me draw it. It can be over here. Now it still has two lines of symmetry because it cuts the counter also equally. It cuts the counter equally. In part C, it says, where could you place a counter on the chessboard so that the chessboard has no line of symmetry? The chessboard has no line of symmetry. I can place it here, 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 or here. Let me place it here. Let me place the counter over here. Now this one has got no line of symmetry. Why? Because if we want to make a symmetrical line, or if we want to make a mirror image, we don't have any one here, or we don't have any counter here, or we don't have any counter over here. So now this shape does not have any line of symmetry. Let's see what we have in part D. It says, where could you place a counter on the chessboard so that the chessboard has only one line of symmetry? Only one line of symmetry. That's quite easy. We can put somewhere around here. Somewhere around here. If you put it here, it has only one line of symmetry. Why? Because this line can be the line of symmetry, and it cuts the counter also into two equal parts. So there is not any other line of symmetry. Now this line cannot be the line of symmetry when we have a counter over here. We are now done with question 9. Let's scroll down to move to question number 10. In part A of question number 10, it says, color two more squares so that the pattern has exactly one line of symmetry. Exactly one line of symmetry. So to do so, we will color this part. If we color this part, this shape will have exactly one line of symmetry. And the line of symmetry is here. Now this line cuts the shape into two equal parts which are exactly the same as each other, but it does not have any other line of symmetry. Let's scroll down and see what we have next. In part B of this question, it says, color two more squares so that this pattern has exactly two lines of symmetry. Exactly two lines of symmetry. So the ones that we can color, one can be here. If we color here, and if we color here, it will have two lines of symmetry. How? So one of the lines of symmetry can be from here. Now this line cuts the shape into two equal parts, which are exactly the same as each other, and one line can be here. So again, this shape also has got diagonal lines of symmetry, but it does not have horizontal or vertical lines of symmetry. So we are done with this part also. Let's scroll down to move to part C. In part C, it says, what is the fewest number of squares that have to be shaded to make this pattern have exactly 4 lines of symmetry? I can say that the fewest number of squares that we can shade and gives us 4 lines of symmetry is 4. It is 4. Here it says, shade the grid to show your solution. Okay, we will shade it. So one here, one here, one here, and one here. Now this shape has 4 lines of symmetry because one line can be here, one line can be here. Now, if we draw the line here, both sides can be the same. One line can be here, and one line can be here. Now this shape has got horizontal line of symmetry, vertical line of symmetry, and also diagonal line of symmetry. So with this part, we are done with all 10 questions of the exercise of the primary mathematics workbook. I hope it helps you learn how you can make mirror image and how you can find the line of symmetry in a pattern. So please don't forget to subscribe to my channel, like the videos, and share the videos with your friends. And if you have any question, you can ask me in the comment section under this video. Have a nice time, and thank you so much.